All right, this is the second set of notes that you are taking in preparation for the energy activities that we will be starting in class the next time that we meet. So you should have already taken notes on types of kinetic energy, and now we will take notes on types of potential energy. So you should have this note sheet in front of you and be filling it in as we go. So the definition of potential energy is stored energy or energy of position. So unlike kinetic energy where things are moving, in potential energy, these are things that have energy or the ability to move or do work or release energy, but they haven't done it yet. So I think of it kind of like a student who has a lot of potential, right? If a teacher says you have a lot of potential, it means they anticipate that you could do a lot of good work in their class, but you have not yet done it. Well, potential energy is kind of the same thing. And if you have not already learned about potential energy, you will talk a lot more about this when you take a physics course. So again, we will start in the upper right-hand corner. Gravitational energy relates to gravity, right? So it's the energy of place or position. So something at the top of a hill, imagine a ball sitting at the top of a hill, would have a lot of gravitational energy because if you let go of it, it's going to start rolling down. Or if you're holding a tennis ball or a pencil over your head, they have potential energy because if you release them, they will start moving. Yes? But these examples aren't the ones we'll focus on in this unit. We'll actually think about how we might use gravitational energy to satisfy the energy needs of our culture. And so we have this picture that represents hydropower. Again, we saw this in the kinetic energy notes, but it turns out that the water behind a hydropower dam, give me a second to write. Okay, the water behind a big dam, stopped up in a big reservoir of water, has a huge amount of stored energy because if, heaven forbid, the wall of the dam were to break, the levee were to break, or if on purpose the dam were released, then this water would start moving very quickly and release huge amounts of energy. And so humans can purposely dam water and then use it to be released at times when they need to convert that energy of the moving water into electricity. And we'll talk more about that in this activity. Stored mechanical energy is another type of potential energy, and you're probably familiar with this one. This is energy that's stored by objects by applying force. So, for example, a stretched rubber band. Right? If you hold a rubber band stretched out and you're pointing at your friend, it doesn't seem to be moving, but it actually has a lot of stored energy because as soon as you release that rubber band, as soon as you release the force that you're applying to it, that rubber band is going to go flying, and the potential energy that it had will get converted into kinetic energy or energy of motion. And so another example of this would be a compressed spring, right? If you have a big coiled spring and you have it pushed down, as soon as you remove the force of your hand pushing it down, it's going to go flying back into its full stretched position. But we won't refer to stored mechanical energy a whole lot in this activity. Now, the next two are going to be big ones. Nuclear energy is energy that is stored in the nucleus of an atom. So there's a lot of chemistry here. But to simplify, this is basically the energy that holds the nucleus together. Right? If you think about it, a nucleus is full of a bunch of protons, a bunch of positive charges. And those positive charges repel each other. Right? They don't want to be all really close to each other. So there's just very strong energy, nuclear energy, that holds them together and overcomes that natural repulsion of all those positives. And so we're going to actually talk really specifically about the uranium nucleus. So we're going to talk about how we can use energy in the nucleus of a uranium atom. And actually, living in southeast Detroit, we're very, very close to a nuclear power plant that uses this energy in a sort of controlled way to gradually release this energy and convert it into electrical energy. And a lot of our homes and buildings in this area are actually powered by some percentage of this nuclear energy. So we'll talk more about that. Now, the biggest thing that we are going to talk about in this unit is all the various forms of chemical energy that our society is very dependent upon. So chemical energy is energy stored in the bonds of atoms and molecules. Okay, actually, the food that we eat represents chemical energy, because as our body breaks down the food, breaks apart the atoms, or the molecules more specifically, in our food and starts to release energy. But we don't really use food to power our cars. Instead, we use a variety of different other types of chemical energy. So we use petroleum, which you'll learn more about, but gets refined into gas. So here's a little visual of petroleum. It's liquid, it's a little droplet. We use natural gas. This is what comes out of the gas line powering many of your stoves or your furnace at home. So here's a little representation of natural gas. We use coal. A lot of power plants in the Detroit area burn coal. A lot of electrical plants actually also do. We use propane. So if anybody has a gas grill and you've seen that little white tank that sits underneath it, sometimes you have to refill. There's a little icon of that. And some people that live in more rural areas where there are not natural gas lines to their house use propane to heat their home. So if you've ever seen a really big white tank out in somebody's yard, that's a propane tank. And then a newer one that you're probably less familiar with, but we'll learn a little bit about, is converting biomass, basically plant material, into a source of chemical energy. And that's a sort of big advance that people are making and studying right now. So we will talk more about that in our energy activity. But for now, you are set with all of the notes that you will need to be ready for class the next time that we meet.